This lecture video is about quadratic equations and problem solving. So basically we're going to look at word problems that end up having a quadratic equation for us to solve. So in the first couple of problems we're just going to look at setting up some problems, and we're not actually going to solve anything. So we have the length and width of a rectangle whose width is half the measurement of the length. And so anytime you can draw a picture of the situation, you should always do that. And so we have a rectangle, and it has some length and some width, and we know that the width is half of the measurement of the length, and we want to use the variable x in these problems. And so here is the length, and here is the width of my rectangle. And so it says the width is half the measurement of the length. So the width is equal to 1/2 the length of the rectangle. And so we're going to let the length be equal to x, and the width then is 1/2 times the length, and so that would be 1/2 x. And so these two then would be expressions for the length and the width in terms of x for this particular rectangle. Two consecutive integers. The word consecutive means one right after the other, and so x would be your first integer, and then the next consecutive integer would be x plus 1. The base and height of a triangle whose height is 3 less than 5 times its base. So here's a picture of a triangle. And so this would be our base, and this would be our height. And the height is, so h is 3 less than, so 3 less than really means subtract 3. And it's always going to be subtracted from whatever comes next, and it's 5 times the base. So it's going to be 5 times base minus that 3. So that's 3 less than 5 times the base. So the height is going to be, and so then we're going to let the base be equal to x. So the height then would be 5x minus 3, and the base would be our value x. So now we have some problems that we actually want to go ahead and solve. Our first one, we have the area of a square is 144 feet squared, and we want to find the length of its sides. So the area of a square is equal to s squared, and we know what the area is. It's 144. So we have 144 is equal to s squared. And in order to unsquare something, we want to take the square root. So we are going to take the square root on both sides of this equation. And here the s squared and the square root, basically, it's like they cancel each other out. And so that is just going to leave us with s. And the square root of 144 is 12. And we always do plus or minus when we're taking the square root on two sides of an equation. But since s is really the length of the side of a square, we only want the positive part. So that would be 12 feet in this case. Now we want the area of a circle is 81 pi square inches, and we want to find the radius. So the equation for the area of a circle is pi r squared. And we're given the area. And so again, replace the a in this equation with 81 pi. And that's equal to pi r squared. And we want to find the radius. So we want to solve this equation now for r. So I'm going to divide both sides by pi. and that will cancel these pi's out. And so we get 81 is equal to r squared. And then, just like with the last problem, we want to unsquare the r, which means I need to take the square root on both sides. And I get r is equal to plus or minus 9. And we only want the positive part because this is a length, and so that would be 9 inches is the radius of that circle. In our next example, the sum of a number and its square is 182. So that would be x plus its square, x squared, is equal to 182. And I always like to write the x squared term first, so x squared plus x, and then we need 0 on one side because we're either going to try to factor this or we're going to use the quadratic formula. Either way, we'll need 0 on one side. And so minus 182 equals 0. So now the question is can I factor 182 so that the sum would give me 1? And so you can take out your calculator and just try to find some numbers that divide into 182 evenly. Or you can do a factor tree. That would probably be the easiest thing to do. And because it's even, we know it's divisible by 2. And 2 goes into 182 91 times. And so right now, for whatever reason, I am not seeing how this should factor, so if you can't see how it factors fairly quickly, I would just go ahead and plug it into the quadratic formula. The quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. And so a for this problem is 1. That's always the number in front of x squared. So a quadratic has the form ax squared plus bx plus c. And b is also 1. It's the number in front of x. And c is negative 182. So we will have negative 1 plus or minus the square root of 1 squared minus 4 times a, which is 1, and then times c, which is negative 182. And then this is divided by 2 times a, and a is equal to 1. So we have negative 1 plus or minus the square root of 1 plus 4 times 182. And that gives you 728. And this all gets divided by 2. So on the top we have negative 1 plus or minus the square root of 729 all over 2. And the square root of 729 is 11.3578. And I rounded that to 4 decimal places divided by 2. And so what do we get here? Negative 1 plus 11.3578. And then divide that by 2, and we get 5.1789, and then -1 minus 11.3578, and divide that by 2, and we get -6.1789. And so just be careful on My Math App when you get decimal numbers that you watch how many decimal places they want you to round your answers to. So it is a computer, and it will either just mark you correct or incorrect. So just be mindful of how many decimal places you should be rounding your answers to. And so it also wanted the square of these numbers. And so so this would be our value for x, the 5.1789, and the -6.1789. And then, so these would be x. And if it also was asking you for x squared, then you would just square those numbers. So the -6.178, if you square that, you should get 38.1788. And the 5.1789, if you square that, you should get 26.820. 8210. So those would be x squared. All right. So our next one here, a roofer drops a hammer from the top of a 64-foot roof. The height of the hammer after t seconds is given by h equals -16t squared plus 64. When will the hammer hit the ground? So on this one, when is the hammer going to hit the ground? Well, first of all, what's the height of something when it hits the ground? And the answer there is that the height is 0. And so we would take this -16t squared plus 64 and set it equal to 0, because when something's on the ground, the height of the object from the ground is 0. And we can factor out a -16 from this, and that would give us t squared, and I think that's 4. Yep. And now it's going to be -4 because we're factoring out a -16. And then -16, we can factor t squared minus 4. It's t plus 2 times t minus 2. And so again, remember, this number doesn't give us any solution. We get t equals -2 and +2. So get -2 from this one and +2 from this one. But this is time, and we don't consider negative time, and so it will take 2 seconds for the hammer to hit the ground. In the next problem, the hypotenuse of a right triangle is 6 inches more than the shorter leg. The longer leg is 3 inches more than the shorter leg, and we want to find the lengths of all 3 sides. So again, first of all, draw a picture so that you can see what you have going on. So first it says the hypotenuse of a right triangle is 6 inches more than the shorter leg. So here's the shorter leg, so we're going to call that x. The hypotenuse is 6 inches more than that, so that would be x plus 6. And the longer leg is 3 inches more than the shorter leg, so this one would be x plus 3. And we want to find the length of all 3 sides. So one formula that's super famous about right triangles is the Pythagorean Theorem. And the Pythagorean theorem is not always what you want to use, but oftentimes if there's no information given about the area or anything like that, then the Pythagorean theorem is a good place to start. So the Pythagorean theorem says a squared plus b squared equals c squared. A and b are the legs, and it doesn't matter which one is which in this case. You could replace a with x or x plus 3, and same with b. It doesn't matter. It's addition. They're both on the same side of the equation, and so a and b are just the legs of the right triangle, and c is always the hypotenuse. Okay? And so we have x squared plus the quantity x plus 3 squared equals x plus 6 squared. So I have x squared plus, now remember when you square this, you really need to do FOIL. So you're really taking x plus 3 times x plus 3. And so you're going to get x squared plus 3x plus another 3x plus 9. So that's x squared plus 6x plus 9 equals, do the same thing with the x plus 6. So you'll end up getting, this middle term twice always. So there is a nice little formula for this, and it's that you square the first term, so that's x squared, and then plus the middle term is x times 6 times 2, so that would be 12x, and it's because of what happens when you do this. If you don't want to use this little formula, again, just do FOIL on the side over there. Plus 6 squared, so that would be 36. Alright, so now I have x squared and x squared, so that's 2x squared, plus 6x plus 9 equals x squared plus 12x plus 36. We need 0 on one side of this, so we're going to subtract all of this, x squared minus 12x and minus 36. So 2x squared minus x squared leaves us with x squared, and 6x minus 12x is minus 6x, and 9 minus 36 gives us negative 27, and that equals 0 now. So we need 0 on one side so that we can either factor or use the quadratic formula, and it looks like this one will factor as x minus 9 times x plus 3, and so we get x equals, from this one we get x equals 9, and from this one we get x equals negative 3. Negative 3, however, is not going to make sense because x is the length of one of the sides of the triangle, and you can't have a negative length. So the lengths of the sides are x equals 9 inches, x plus 3 would be 12 inches, and then the hypotenuse was x plus 6, and so that would be 15 inches. Of a building that has a ladder leaning up against it. And let's just read through this whole thing. It's fairly wordy, so we're just going to take a little bit of time here. A ladder is leaning against a building so that the distance from the ground to the top of the ladder is 10 feet longer than the distance from the bottom of the building to where the top of the ladder is against the building. The distance from the bottom of the ladder to the building, so this part is fairly easy, from the bottom of the ladder to the building is 30 feet. So this distance from the bottom of the ladder to the building is 30 feet. And we want to find the height from the ground to where the ladder is leaning up against the building. And so from the ground up to where the ladder is leaning up against the building is our height x that we're trying to find. And then this other distance from the top of the ladder is 10 feet longer than the distance from the bottom of the building where the where the top of the ladder is up against the wall. So that's x plus 10. over here. And I will provide you a picture of this one. The wording is fairly complicated in here, and so anyways, I will provide the picture, and the part that I want you to do is to set up the equation and then solve. And so again, this is just like the problem that we did before. In example E, we're going to use the Pythagorean theorem. And so that's a squared plus b squared equals c squared. A and b, again, remember, are the legs. And so that's going to be x squared plus 30 squared equals c squared, which is the hypotenuse, and that's x plus 10 in this case. So we have x squared plus 30 squared is 900. Plus, remember when you, oops, sorry, that should not be a plus, that should be an equal sign. You have to remember to do FOIL. So on the side, do x plus 10 times x plus 10. And so you will get x squared plus 20x plus, 100 when you FOIL that out. And we want to have everything on one side of the equation. So we are going to subtract our x squared, subtract 20x, and subtract 100. So the x squareds will be gone then, and we'll have negative 20x plus 800 equals 0. And to solve this for x, we would subtract 800 from both sides. So we get negative 20x equals negative 800, and then divide by negative 20. So we get x equals 40. Oops. And this was in feet. And this is our last one. At the end of 2 years, P dollars invested at an interest rate R, compounded annually, increases to an amount A dollars, given by A equals P times the quantity 1 plus R squared. Find the interest rate if $200 increased to $280 in 2 years. Write your answer as a percent. So A is the amount that you have in the account after some certain amount of time, in this case 2 years. And so that would be the 280. And P is the amount you started with, and so that would be the 200. And then that's 1 plus R squared. So first we want to divide both sides by 200. And so we get, what would that be? 1.4? Yes, so we get 1.4 equals 1 plus R, the quantity squared. And now to unsquare something, we just need to take the square root on both sides. So in order to unsquare this, we're just going to take the square root on both sides. And the square root of 1.4 is 1.1832 rounded to 4 decimal places, and then we would subtract 1. So 0.1832, and they want us to give this as a percent. So right now this is the interest rate as a decimal. To get the percent, we want to move the decimal point 2 positions to the right, and so that would be 18.32%. And then just make sure that you round this to the correct number of decimal places that's being asked for on my math lab. So that is the end of this lecture. Let me know if you have any questions. Thanks.